All right. So a little bit now about the fundamentals of calculus. What is there when you're looking at calculus? You'll be given the functions, okay, the different functions, and then you are supposed to actually measure the rate of change that happens in a variable and actually its own impact on the outcome variable. Yeah, I know that may sound a bit technical, but I can lower it a bit. So we are trying to measure the rate of change, okay, that happens in the y variable. So given a function, for example, y is equal to 3x plus 5. When you are dealing with the differential calculus, you are trying to, measure the rate of change of y, the variable y, just as a result of the change in the variable x. Is that clear?
Yes.
Okay, so calculus is in levels. Actually, we have the different levels of calculus actually from level 1 up to somewhere level 6. Actually, calculus goes on when you go into the university. You can even do multivariate calculus. And it's actually one of the most important tools that we use to solve a lot of problems in the universities. Yeah, so calculus is very important. That's my message that I'm communicating to you. Is that clear?
Yes.
So number one, you have got what is known as differential calculus. We have studied calculus today. There is what is known as differential calculus. And then from there, you have got integral calculus. Integral calculus. Yeah, integral calculus, where you're integrating the equations. And within the integral calculus, you have two types of equation, functions. You will have definite integrals and the indefinite integrals. I'll explain all of them in detail when we just start. Indefinite integrals. So these are the major ones that you look at all in all levels when dealing with all levels. So having been given differential calculus being the first one actually that we need to start with, we can start with the commanding words, differential calculus. The commanding words. So the following are the commanding words that you find. You find words like derive the equation. So you'll be given an equation, you'll be asked to derive. Or you can be asked to find the derivative as dy over dx of a given function, or to just find the derivative, okay? The derivative of the function, derivative. Or if not that, you can be told to differentiate. Is that clear?
Yes.
All these are the commanding words. They just mean the same thing, okay? Derive, find the dy over dx, find the derivative, can you differentiate? All those things, they just refer to the same thing. So now, when you're dealing with calculus, there are actually 4 up to 5 different methods that we use to solve equations depending on the nature of the function that we have been given. And so the first one is what I'm introducing you to, solving the equations using what is known as the power rule. Okay, you're writing down, there is the power rule. So how do you use the power rule to solve the equations or to differentiate the equations? So this is the general formula. It says that if you're given an equation saying 3y, let's say y is equal to ax to the power n. If you're given any expression like this, then the dy over dx of this function shall be given as, you drop the n times this same a, you keep x the way how it is, and you reduce 1 by 1, n by 1. So the value of n is called actually the exponent. You don't want to call it an exponent, you can call it a power. Okay, it can be called a power. Yeah. So the value of an exponent is from before the power such a power. That is an exponent. Is that clear? So then this letter you have here is called a variable. It is called a variable, and a here is called a coefficient. Okay, we usually call it a coefficient. Is that clear? So there is a being the coefficient. The coefficient is basically the number that stands just before the letter, the variable, and then n is the exponent or the power. So basically, that is what you do. So you keep on doing this in every expression that you've been given. Are we okay?
Yes.
Okay, so I'll rewrite that again, then I'll put some examples. So I've said, if you're given an equation yx to the power n, then the dy over dx, over the x of this equation shall be given as n times x, times ax to the power n minus 1. So let's be given some few examples. Let's have some few examples. We'll have 3x to the power 5 plus 4x plus 5. How do we find the dy over dx of this particular function? Are we okay up to now? It is as easy as what I have said. This exponent to be dropped, number 1. It will be 5. Then you open the bracket. You write 3 the way how it is. X 5 minus 1. Are you able to follow so far?
Yes.
I've just repeated what I've written in the formula for you. And you know that this 4x, this x is raised to the power invisible 1, yeah? So plus you drop the power 1 times 4 the constant x to the power 1 minus 1. Is that clear?
Yes.
And get it that every time you're differentiating the constants, any number that doesn't have the variable, in this case, that doesn't have a letter, it's 0, okay? So the derivative of a number or a constant is always 0. Is that clear?
Yes.
So we have 5 times 3 giving us 15x raised to the degree 5 minus 1, 4, plus 1 times 4 is 4x to the power 0. Is that clear so far?
Yes.
And you and I know that any number raised to the power 0 is what?
1.
It's 1. So you have 4 times 1. That will just be 4. So you have 15x to the power 4 plus what? Plus 4. Isn't it?
Yes.
As our dy over dx. Are we good up to here?
Yes.
Okay. Please, if I'm speaking so fast, you always tell me that, sir, you're moving so fast, and then you can slow down. This is very important. You need the calculus. It comes both in paper 1 and paper 2. So you just need calculus. Let's have another example that is a little bit more interesting. So it is very interesting, and it causes 2 over 5 x to the power, let's say 3 plus 2 over x squared, yeah, plus 6. You've seen this one? This one is becoming more interesting, yeah? I've seen this one.
Yes.
Okay. So how do you go about this one? So the first thing that we need to do is to rewrite this function. You have 2 over 5 x raised to the degree 3 plus 2. Now, if you do remember exactly what was said about these very expressions, you know that you can still relate a fraction like this one. Let's say 1 over x squared. It can still be written as 1 times x to the power negative 2, right? Under
Yes.
indices, do you remember the rule of indices? So this can
Yes.
be x to the power 2, or this you can see related as x to the power 2, like that. So we can relate this then. If we do remember the rule of indices, we have 2 x to the power negative 2. You agree with me?
Yes.
Having related like this now, it becomes very easy to, to go about it. So you can drop as usual, have 3 times 2 over 5, right? X to the power 3 minus 1, it will give us 2, right? I've gone straight since you know that always the powers are deducted by 1, isn't it? Hello? Hi, have you followed? Hello? Hello?
Sir?
Are you following?
Yes.
You know where the 2 has come from?
Mm?
Okay. So then from there again, you drop the exponent 2 down here. It will be negative 2 times this 2. Then you have x to the power what? Negative 2 minus 1 is what?
Negative 3.
Negative 3. Sharp. And plus, you know the derivative of a constant, we have already said that it is 0, isn't it?
Yes.
Okay. Great. So it is as easy as that. So I'm going to pick it up from there. What is 3 times 2 over 5? 3 times 2 over 5. Three times 2 over 5. Hello, are you still there?
Oh, yes, it's 6 over 5.
Okay, it is 6 over 5. That's very great. So it is 6 over 5 x raised to the second degree minus 4, x to the power 3, like that. If we want, you can even rewrite this part, the letter expression on the letter side as what? You can have 6 over 5, x raised to the second degree minus 4 over x to the power positive 3. You agree with me?
Yes.
Exactly. So basically, this is how you deal with the power rule. So the power rule is not actually very complicated. So it's just that issue where you get the basics, and the basics are that whenever you're given an expression y is equal to ax to the power n, what do you do? Number one, drop the power. This is the power rule. Drop the power, get the coefficient the way how it is, have the x raised to the power n, deduct 1. You keep on doing all that, and then get it that the what's this? The derivative of the constants are zeros. Okay, whenever you're deriving a constant, the answer is 0. It is as simple as that. Is that clear?
Yes.
So now we invite you to the next conversation that we are going to have. Just a minute.